How effective are general home water filters at reducing chlorine levels in water? By Zachary Bayonet. We can feel pretty good that public water is regulated by federal law under the Safe Drinking Water Act. Under this act, the Environmental Protection Agency sets safe levels for over 90 contaminants for municipalities to follow. But there is one more concern. Before water can be sent to our homes, it must be treated with a minimal amount of chlorine to prevent the growth of bacteria, viruses, and protozoa, which can live, thrive, and grow on the way. It should be noted that even bottled water companies chlorinate or use similar antimicrobial agents to reduce the risk of waterborne pathogens. Bringing us to the question, is the consumption of chlorine in tap or bottled water over extended periods of time safe? As a result, my goal for this project is to determine if a standard home water filter can quantifiably reduce the presence of chlorine, giving us both pathogen-free and chlorine-free drinking water. Treatment with chlorine can result in byproducts or secondary reaction products that may be dangerous. If chlorine disinfectants undergo a reaction with natural organic or inorganic materials already in your drinking water, carcinogens which cause cancer can form. The EPA cautions that infants, young children, and the fetuses of pregnant women could experience nervous system effects with high exposure to the byproduct chlorides in drinking water. This population should take extra precaution to ensure that the chlorinated water they drink are at safe levels. Since the maximum amount of chlorine found at home is typically present at small quantifiable levels or parts per million, it would be difficult for me to quantifiably test for these levels in a home lab. However, I can quantifiably test for greater amounts of chlorine such as that in a typical store bottle of bleach. Bleach contains a mixture of water and a type of chlorine known as sodium hypochlorite. Although the amounts are much larger, I will still be able to quantifiably determine if filters are reducing the chlorine content. This experiment will occur in two separate reactions. Let's take a look. Reaction 1. React chlorine with the excess potassium iodide. You can see the formula below. The sodium hypochlorite oxidizes the colorless iodide ions, turning them brown. We do not know quantitatively, however, how much sodium hypochlorite and iodide reacted since it's in excess. Therefore, we need to back titrate. Reaction 2. Back titrate with a measurable concentration to determine actual quantities that react in part 1. The iodine ions will now be reacted with sodium thiosulfate and a starch indicator to create iodide again. Unlike the first reaction, the amount of sodium thiosulfate reacting with the iodine will be measured in an endpoint determined with a starch indicator, as you can see in this formula. Using stoichemistry, the ratio of sodium thiosulfate can now be used to determine the relative amount of sodium hypochlorite from part 1. My hypothesis is, if water filters reduce chlorine levels in drinking water, then the amount of chlorine in a sample of filtered water will be quantifiably less after filtration. Some important materials to consider are glacial acetic acid, potassium iodide, starch indicator, and 0.1 mole sodium thiosulfate solution. To begin my procedure, add 100 milliliters of chlorine bleach to a flask and weigh. Use mass and volume to determine density of chlorine bleach. Then filter chlorine, then begin reaction 1. The solution turns brown as chlorine oxidizes the iodide to iodine. Then begin reaction 2. The starch will bind to the iodine, turning the solution blue, and will disappear when all the iodine has reacted with the sodium thiosulfate. Repeat the trials, and then complete calculations, such as convert milliliters titrate to moles, and use the periodic table to determine the mass of chlorine present. Reduced levels of chlorine were observed upon filtering. For example, filter A had 58.6% chlorine reduction, and filter B had 98.1% chlorine reduction. Here you can see my observation table. You can see my data tables and the calculations more clearly. Here you can see my data analysis. Note though that the purple filter has nearly reduced all the chlorine, while the blue drop filter has cut it in 1/2. Conclusions. My hypothesis is if water filters reduce chlorine levels in drinking water, then the amount of chlorine in a sample of filtered water will be quantifiably less after filtration. We have found out that my hypothesis is in fact true. On average, the experimental values of the two tested brands of water filters showed that there was a reduction in the amount of chlorine present when compared to the unfiltered control. Consider a filter to reduce long-term exposure, which can cause health ailments on this page. This is a snapshot of the water quality report in my area stating the following. I can expect to have trace levels of chlorine byproducts in my own home tap water. A home water filter may be useful. Not all home water filters may work the same. In this experiment, the per home water filtration system had far exceeded the drop system at reducing chlorine levels. My recommendation is to check performance data sheets that accompany filters. Look for certification, such as the NSF is a public health and safety organization that independently tests water filters. It requires filters to meet a reduction requirement of greater than or equal to 50% to be certified. Here are the tables that came with my filters. The filters I purchased came with NSF 42 certification. My results confirm NSF testing. There are limitations to NSF Standard 42, which only certifies for the reduction of chlorine, taste, odor, and particulates. If you are looking for protection against parasites, lead, or other volatile organic materials in your water, check for even greater standards as NSF Standard 53. Here are some errors that could have happened: over-titration, uniform swirling, errors in reading the meniscus, and failure to uniformly measure. My favorite improvement on this page would include repeat filtering. Determine if repeat filtering can completely eliminate detectable levels of chlorine. Here on this page, you can see my works cited. Thank you for watching, and this concludes my